My name's Evan Phoenix, and I'm here to talk about Rubinius. A few talk notes first. If any of you have seen me talk before, I like to run my talks like roller derby. That is, that they're fast, sometimes hard-hitting, but everybody always has a good time, all right? So that means that if you've got questions, put that hand up, and I'll call on you as quickly as you can. And I don't care if you want to heckle me, that's fine, but put the hand up. I'll still call on you, even if I know you're going to heckle me, okay? And as always, I reserve the right to not answer your question. Hopefully I'll get to it by the end, but in some cases I'll just blow you off. So that being said, let's do the last things first and the first things last. Let's pretend I'm starting at the end of the deck here. And that is, what is the end game of Rubinius? What is the end game of IronRuby? What is the end game of JRuby? And that very simply is total world domination for Ruby. And we're all here to advance that cause. And just like probably almost everyone in this room drives a different make, model, color, style of car, it's okay for most of us in here to use different interpreters to do different things. We all have different problems to solve, and we all have different ways of solving them. So that being said, let's actually talk about Rubinius a little bit. So first, I'd like to take you 375 days ago in a galaxy far, far away, otherwise known as Colorado. And that was RubyConf 06. There I am. I had shorter hair. There's Chad. He had much longer hair. There's Ryan. He was dressed in black again. And there's most of you. Well, actually about half of you, since we've doubled capacity is what I've heard. And it was there that I gave a talk all about the end of a project that I had started called Sydney and the beginning of one called Rubinius. And it was there that I kind of debuted this project to the world. Up to that point, I was the only one who was working on it, and I was doing it, in my spare time. And it was actually on the plane to RubyConf that I had written the first kind of solid work on this that wasn't really a throwaway prototype. And I'm really happy to announce that we have made enormous progress in the intervening year. Really, really astounding progress. And I have the contributors to Rubinius really to thank for that. And we'll get into that here in a sec. So that being said, I should really, maybe I should tell you a little bit about Rubinius first, in case any of you are unfamiliar. Well, it comes from Smalltalk originally. And then we added some Ruby syntax, and then we added some Ruby behavior, and then we added some crazy CS papers. Because really that's what was required to really get this VM up and off the ground. Now, while I was preparing this talk, I had a couple of decisions to make. I could do a lot of technical things. I could do a philosophical debate a la Marcel. I could do any number of different things. So for the most part, what I've decided to do is not so much talk about technical things, although if you're interested, I have all those slides and we can get into them at the end. But just to appease the CS nerds in the crowd, we're going to do a quick CS nerd attack mode. All right? Now this is going to go fast, right? So I need everybody to really be paying attention. All eyes up here. All right? Are we ready? All right, we got generational garbage collector with heap collection. It's really awesome. We've got bytecode execution that keeps everything fast. We've got stackless execution. That means no C stack. That keeps everything pretty awesome. We have a self-hosted kernel and compiler, which means that everything in the kernel and the compiler is actually written in Ruby. We have pre-compiled files, which means you can compile your files off to disk and have this intermediate representation, not have to keep around the text versions anymore. We have built-in packaging, sort of like a jar, and that's the end. So like I said, if you want to talk about that more, put that hand up, ask a question. We may wait till the end, or you can talk to me about it offline. So now we move into the audience participation. section of my presentation. So who in here would rather program Ruby instead of C? Hands up. Okay, whoa, that's not going to work. Okay, let's do the other way around. Who in here would rather program C than Ruby? Okay. All right. Let's give that man a hand. That's some honesty, right? And can I, let's do another quick one. Let's say Java instead of Ruby. C# instead of Ruby. That's fine. No, I want honest opinions here. Okay. So let's keep that mental picture of the sea of hands as we move into this next part. So there's a thing in a VM, and especially in Ruby, there is the runtime and there is the kernel. And in the runtime, we have everything like how to perform an if, how to send a method, all the real nuts and bolts. For those of you that have really done C, what you're provided with in C is a runtime. And for the most part, very little kernel. You get a library that you can kind of pull things in from. But for the most part, you're adding things to it. Whereas in Ruby, you have an enormous amount of things that are provided by default. And that's what we in Rubinius call the kernel of the code. And just in case we're looking for what the kernel really represents, really is that second definition. It's the most important part of something. You can talk to your closest CS person or CS nerd, which is typically a sysadmin, and they'll tell you, oh, I wrote a VM in a week. All I ate was cheese. It was awesome. And that's absolutely true. Every CS class can cover how to write a really simple virtual machine. It is not rocket science. It's a fairly simple program written in another language. And really what all of the Ruby implementations have done, or all the alternate ones for the most part, have strove to do is really implement that kernel of behavior, all the methods on array, all those things that string can do, all of the existing frameworks that are provided. And so what we're going to do is I'm going to break it down for you. We're going to look at what the runtime and the kernel look like in the other Ruby implementations. Now, this is what I call the hard-hitting part of my presentation. So first, let's look at 1.8. Now, I don't want that guy putting his hands up talking about lines of code, all right? Keep that hand down. This is not a scientific explanation of what's going on. This is very unscientific for the purposes of everyday programmer information. 1.8 represents 84,516 lines of C code for the runtime and the kernel, and 0 lines of Ruby. That's right, 0. 1.9. We've gone up to 128,000 lines of C. Again, still no Ruby to be found in either the runtime or the core. Iron Ruby. Now, these are the releases that I had available on my laptop at the time. But one can only assume that these numbers have gone up rather than down. 48,000 lines of C#. Read that with the extent. Yeah, okay. So, John kind of got up here and said, we really want contributors. But did we see that sea of hands? Who in here wants to write C#? We all want to be writing Ruby, right? So there's some truth about the way that these kernel and these runtimes are implemented for Ruby programmers. Move on to JRuby 102. 114,000 lines of Java. Not a single solitary line of Ruby to be found. Okay. Absolutely. And I expect it not to be true. Nick, what would you say? Maybe. Can we say 1,000? Is that generous? Okay, let's say 1,000. That's generous. This is what I'm talking about. We are having a discussion here. I'm not talking to you. We are talking. And so it brings us to Rubinius. Now, what does Rubinius look like? Well, 25,000 lines of C, and I'm happy to report that that number goes down rather than up. How do we do that? We do that by making sure that the second number goes up. And that's because as we move forward in time, we approach every problem with the question of how can we do this in Ruby rather than in C. And we've really built up an infrastructure and a build system that allows us to build as much of it in Ruby as we can. And that has really proved to be enormously beneficial, as we'll see later. And for those of you who, numbers are this blah-de-blah thing. I love shapes. So we'll just look at some shapes. Oh, wait. There we go. So we'll look at shapes. So that is these numbers put to bar graph. And, personally, it's sad that I'm the only one who has any. Well, okay, we got 1,000 on JRuby. So let's say, which part is that? Sorry, Rich is saying that there's. Is that new? Is that new in 1.9? Okay. So no, that's fine. That's great. Yeah, absolutely. This is a conversation. So there's a prelude.rb that's in 1.9 that is. I'm gonna go with 50. We'll throw that out there. I'm a generous guy. So let's say that we were to take these numbers and we're going to write them down on a pad. I'm going to take everybody back to junior high. It's okay. We're not actually going back to junior high. I know. I don't want to go back there either. But we're going to do some junior high analysis with these numbers. Okay? Just, we're not going to put much scientific thought into them. We're just going to take these at face value. What would they mean? If we were to give these to someone, what would they say? Well, they'd probably say that 1.8 and 1.9 is Ruby for C programmers. Because you have to be a C programmer to write Ruby in 1.9 or in 1.8 or 1.9. And for the most part, that has been okay because they provided this infrastructure for people to flourish in Ruby. I mean, that's obviously how I started. And we still use it for that. But the problem is that if you wanted to go in and you want to patch things, you want to add things to the language, you want to help grow this community and this ecosystem, you need to be a C programmer. Plain and simple. And the Ruby core mailing list accentuates that fact. Sure. Sure. So the statement was that you contribute a lot by just writing Ruby. And that's absolutely true. And what I'm really looking at here is the evolution of the language. Not exactly so much the direction that the external community takes, but rather that internal community of moving the language forward and really taking Ruby to places that it isn't yet at. Yes? Yes, so the statement was that you can't really contribute to Ruby core unless you're a C programmer. And I would say that for the most part is true. Yes. So again, continuing on with the junior high analysis, that JRuby must be Ruby for Java programmers. Now, I'm making these scathing statements on purpose because this is the hard-hitting part, remember? And again, Iron Ruby must be Ruby for C# programmers. Not to slam John, but he showed just pages and pages of C# code in his demos. And that's fine if you want to write C# code. I don't. So what is Rubinius? It's Ruby for Ruby programmers. And as was stated before, that might not matter. It might be fine that it's written in C, and it might be fine that we contribute by, building up these great Ruby libraries. And absolutely, probably everybody in this room has done that exact thing. It's contributed to the ecosystem by writing libraries in Ruby. But there's something fundamental that you're missing about this process. Yes, in the back. In this room, you want to see a show of hands? We could. I don't have them. But so the question was, could we see some numbers about the number of Java programmers and C# programmers and such? Is that about right? And Ruby programmers, and I don't have those numbers offhand. I mean, sure. Do you want to do a show of hands in the room? Okay, so we'll just assume that everybody here is programming Ruby. So who in here regularly programs in Java? Okay, so that's about 40%. How about C#? It's about 15%. And how about C? 20%. Okay. Yes. Well, that's true. So Nick was saying maybe the question should be who can program in those languages. But that's Rich. You stole my line. You've been doing that all week. And that's really the point, is because the ability to program in the language and the ability to want to program in the language or to actually do it are two different things. You know. So to pull it back in, there's something fundamental missing about the development process of these individual languages, or the interpreters, in my opinion. And that was really why I started this project. And that is this: yummy dog food. Keep some in the bomb shelter, because it's good stuff, and you should be eating it. And what does it mean to be eating your dog food? Well, we've all heard that term. And for the most part, anybody in here not know what eating your dog food means in terms of programming? Okay. So eating your dog food in terms of programming means that you're using the tools that you're working to build. And it's a very important process, especially in the case of an interpreter like this. For the most part, most compilers are written as the developers are eating their dog food. So every day they're using the product that they're trying to develop, because remember, I am really no different than any of you. You're my target audience. I'm not really looking to sell Rubinius. I'm saying sell, not like for money, but promote Rubinius to the guys on the street who need a website. I'm looking to promote it to you, my fellow programmers. And so if I am comfortable with the product and I really think it's solid, then my hope is that you will think it's solid. And that's the premise behind it. And it's a very important premise, because eating your own dog food means that you create a feedback loop between the developers and the actual thing that you're trying to build. And it becomes very fast. And we've heard in a number of talks over the past few days about how important having a closed, quick feedback loop is, because it creates rapid change and a rapid development. And in the case of Rubinius, it means that as we feed back into the kernel, into the VM, it means that we're making all Ruby code faster, not just the individual things inside the kernel. Whereas, currently, if you wanted to go in, you really want to make some array method faster in 1.8. You're going down into C land, and you're really working to make this little chunk of C code really perform well. But unfortunately, that's where the performance tuning stops, because if you're not tuning it for Ruby, you're tuning it for just this one little section. Whereas if you're tuning it for all of Ruby, for the whole system, everything gets the benefit of that tuning. So here's my placeholder as I move into the next part. Like I said, I'm the same as you, and I want to be writing Ruby. You're a Ruby developer, I'm a Ruby developer. And we want to do that every day. In fact, there was a question earlier about who's getting paid to write Ruby. We've asked that in previous conferences. I'm not sure it got asked, but I'm going to have people show of hands again. Who here is getting paid to write Ruby code on a day-to-day basis? I want it. Now I stole your line. Do you want to do that now? No? Who wants to come up here and take a picture of that? Camera person? So, come on up. Come on. Run, run, run. Okay, let's do that again. Show of hands. Who gets paid to work on Ruby every day? Okay, so for those of you who are new to RubyConf, that question gets asked every year. And I would say it's currently at an exponential growth. I really can't sustain exponential growth, but it's a normal exponential growth. This is my third RubyConf so I went to the first one in San Diego. And I think that question, there was maybe 10% at the time. And really that number is just astounding that it's gone up in such a way. Yes?
Ask who's getting paid to write Ruby but not Rails.
Okay, that's good. So who's getting paid to write Ruby, not Rails? Okay, that's great. That's a great metric, but Ruby, I think that we'll still see that the number is still going to slope up at an exponential rate, because as people come into Ruby from Rails, they're going to realize that it's a tool not just for building websites, but for building all kinds of different applications. So from that, we can extract that we all want to be writing Ruby. So really what we're looking for Rubinius is it's of the Rubyists, by the Rubyists, for the Rubyists. It's of us. We want to be doing Ruby, and so do you. So I think that's really important, because I think it's important that the project represents what the community it's meant to serve has at heart. So that has been one of our main goals with Rubinius. So people are going to say, like, that's great, Evan, but, you really, how is it doing in terms of performance? The previous people will get up here and show you performance numbers. And I'm not going to show you performance numbers for the most part, because they change rapidly. But I am going to tell you that recently, we've run the yarv micro benchmarks, which at the moment are sort of the staging ground for a Ruby interpreter, and we're currently faster on 24 of 31 of these tests than 1.8. So we're really getting there, and for the most part, that's due to developments in the Ruby code, not just in the VM. There's certainly developments in the VM that we garner from other sources. But again, it's moving quickly. And as some of you may remember that I had previously been saying that we're really shooting to have 1.0 out by now. Well, I'm not. So why isn't it done? And the reason it's done is because over the past year, the project has really grown, and I've really become acutely aware that architecture and design are really important in this frame of mind. It's really hard to make a bad decision and have to live with it when you're working in an interpreter. But by that same token, it's very hard to design one in a vacuum. Almost every interpreter is written with at least a couple of prototypes in front of it. And so I did write one initial prototype, and we've kind of been building off of the second one. And because of that, mistakes were made. We've made mistakes. We would, a lot of them were my mistakes, that we would go through things and, really go down paths that turned out to be fruitless paths, and we'd have to really go back. And that's okay, because, Ryan said this yesterday, practice makes perfect. And there's some other kind of important people too who said you have to make mistakes to really succeed. And I haven't been willing to settle on certain decisions that would impact the long-term growth of this project for that reason. But I think what's really important is the second quote here. You'll do foolish things, but do them with enthusiasm. And I think that's been one of the guiding principles behind Rubinius, because really, to steal something from the Perl 6 community, we're really trying to optimize for fun. It is an optional flag, unfortunately. I would prefer if it were system, set on every system, but it's not. And really knowing that we're trying to have a good time with this and really push it forward and really want to be working on this has proved that it's rarely a burden to be working on Rubinius, and it's always a treat. I have, in the past year, I have never regretted starting the project, and I've, on occasion, I've gotten tired of working on a bug, and I'll go for a run or go watch some TV and come back and be ready to engage again. And I think that is echoed by the contributors as well, that they have found that we've really managed to keep everything light and airy. And that really brings me to the next part of this, which is the community of Rubinius. And this is really VM stuff, blah, polymorphic caches, blah. The community that we've managed to foster is probably the thing that's dearest to my heart. Because VM technology comes and goes, and code comes and goes. But a community with a momentum in that community is far more important than any of those other things, because it is the thing that's most dynamic about a project. When you decide that you want to completely change some subset, you have a lot of work to do. When you decide amongst everybody in the group that you want to go down a new direction, you can make that in an instant. You can make that decision. And I'm happy to say that we had one committer a year ago. That would be me. And as of last night, we have 57 committers. And 17 of those have 20 or more commits, with 36 committers with 100 lines changed or more. And that tells us a few things about the community. First off, it tells us that, for the most part, we have 17 what most people call core committers. I don't particularly like that term. It enforces that there is a separation between the outlier committers and the inner committers, and that there's an important structure there. I don't think that there is. We have had committers who show up out of the blue and submit a 400-line patch that does things I could never have thought of. And the value in that patch should not be diminished by the amount of time the person has spent on the project. So we've been able to garner both weekend patchers and code junkies alike. And that is really, I'm really happy with that fact. And for the most part, we've been able to do it with what's called the free-flowing commit bit. From day one, and this is again something that I've taken from the Perl 6 community, although I'm not a Perl programmer, I've just found that they've managed to have some really great processes with relation to their programmer communities. And so the free-flowing commit bit means that if you send me a patch and anyone, commits that patch, you get commit rights right away. No questions asked. You can go ahead and have commit rights. And you can continue to commit as long as you need. We have yet to cut off anyone from their commit rights. So we've proved that one patch hurdle, just one patch, was enough to keep out what would be considered the normal kind of crazies that want to just screw up your project. And certainly we've reverted things over time, but everybody has reverted things. So we've managed to basically widen that pipeline of committers as wide as possible, and it hasn't really impacted the overall quality of the code. So I really want to highlight the committers. They've made this project what it is. I wouldn't be up here if I would probably be at the very best a fifth of the way through what I'm actually doing at the moment. So we're gonna go ahead and I want to highlight them. I should have put music to this. I could sing if you want. Da, 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 committers, 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 yeah, committers, committers. Okay, so I want everyone in this room who has submitted a patch to Rubinius, whether or not you've gotten commit rights, which you should have if you've submitted a patch, to stand up right now. Everybody up. Come on. Stand up. I got time. I got all the time in the world. Okay, sit. Simon said sit. So, keeping with first things last things first, I always think engine yard at the beginning of the talk, since I was doing it in reverse and thinking of it at the end. They've really made this possible by funding my ability to work on Rubinius. I can't say enough about their commitment to the project and their commitment to the vision of pushing it forward, and I really want to give them a hand. And again, since we're now at the first slide, my name is Evan Phoenix, and I'll be talking about Rubinius. So that is the end of my non-technical things. Now, it says I've gone 30 minutes, so why don't we ask some questions? Yes?
Given that some well-known language junkies like Avi Bryant and Olabini have come out and really said they think Rubinius is the way, I know you've been kind of not going directly towards it, but do you think that ultimately Rubinius should replace the MRI?
I think we're back to the hard hitting section. Yes. The question was, do I think that Rubinius should replace MRI? My question was, I guess my answer should be, did the waterfowl decide that they should replace the dinosaurs? And that's not to say it's a dinosaur. Clearly, I should have picked two better animals. But it was the ecosystem, and it was the environment that decided the direction of those two beasts over time. And so I'm not going to say whether or not it should replace it. I think they all have their places. It's not. It does me no good to say that it should replace it. I don't think that it should. Time will tell. That's kind of where I'll leave it. Yes?
Alluding to the beginning of your presentation, that's not the goal, the ultimate goal, is it?
Is the ultimate goal to have Rubinius replace MRI?
No. I'm making a statement. The ultimate goal is world domination.
Right. So to highlight my snazzy last slides, the goal is not for Rubinius to replace 1.8 or 1.9. I'm not in it for that. I'm in it to have Ruby be a player on the world stage, and that's why we're all here. So. Sure.
Seems like I'm new to Rubinius. It seems like when you describe you had a core kernel that is much smaller, much smaller.
Yes.
And then you start implementing Rubinius, flesh out what you would normally consider part of the standard library of the kernel. So can that core C microkernel of Ruby, can that be used, say, on embedded systems, where you're trying to put something up that's memory constrained?
So sure. So the question was, I'm going to summarize. The question was, can you have a different kernel for the most part? Could you use that C, the CVM, that C core, and really manipulate that kernel and really get it down to a finite size that you can work with? And is that accurate? And the answer is absolutely yes. The whole project was written in such a way that I know that someone will want to do that. And I haven't boxed the project in any way, shape, or form to this particular kernel. In fact, we evolve it over time. It's got many different ways to be loaded. You could very easily right now download Rubinius, change the kernel completely. In fact, if you really felt like making your own language that had the same general syntax as Ruby but called everything with bleh on the front, you're certainly capable of doing that by downloading the kernel and using search and replace. That is in Ruby code. 100%, that's fine. Yes? Okay, so the question was, are there more things in Rubinius you can override? How's that? Specifically fix num plus, is that? So one of the really big parts about Rubinius that I can talk about if you want, that I'm really proud of, is the fact that the compiler for Rubinius is written completely in Ruby, 100% in Ruby. So when you get the input from the parser, you can, the code to generate the actual output bytecode is directly in Ruby. So that being said, on the question of fix num plus and the ability to have MRI uses those via shortcut instructions, so that it says like, oh, okay, well, I'm sending the plus method. I'm going to emit a special instruction that looks to see, are these things a plus-esque? And if so, I'm going to add, or number-esque. If so, I'll add them directly. Otherwise, I'll do the method dispatch. And you could easily, actually you could turn that off. Rubinius has a similar optimization that you can actually turn off. It has some compiler flags. You can say like, I think that's called fast math in Rubinius. So and I'll talk about that briefly. There's something slightly more fundamental there, which is, people kind of had been joking around, like, in Jim's talk, he was talking about, well, I can't override, and, or ampersand, or pipe, or those kinds of things. And that's true, and in Rubinius, you currently can't either. But the point here is that you have access, every Ruby programmer has access to the data structures that form the output from that program. And we use a form of parse tree and the 1.8 grammar to give it back to you as code. And then the compiler can then make any kind of optimizations it wants from there. So if you feel that you want and to become a method call and you want to go ahead and do that, you have to add one class called a compiler plugin to basically support that functionality. It's very simple. So it really is a malleable system that can be changed over time. Well, there's a couple of different techniques that we're going to be using going forward. One of them is a technique that Squeak uses, where they actually write the VM in a dialect of Squeak, a very reduced set dialect, and then they're able to run a processor on that code as data to generate the C code. So over time, we're actually going to be looking to do that. So the long-term goal is to have the number of lines of hand-maintained C be 0. So, yeah. Sure. So the question was, am I worried about incompatibilities? We're all worried about incompatibilities between the different VMs. I'm not interested in necessarily in, like drawing a line and saying like mine is the best, because that really does the community no good. That's just sort of a ego power play. So, so I gauge the people who want to contribute like that. So if someone were to contribute a patch that changed and to be some kind of method call, we would probably reject it on those bases. We try and keep as compatible as we can. Yeah. So, yes.
I'm not really that tough on the different communities about the VMs, but it seems like we saw John earlier using the RSpec test from your project. We heard you asking Matt last night about the specs and talking about the work that you're doing, writing specs for Ruby 1.8. I was hoping you could talk a little bit about the specs that you're writing, and then also as an aside, what percentage of your passing.
Brian, do you want to talk about that? I mean, otherwise I can put words in your mouth. Your choice. Okay.
So for the passing question, these are not hard numbers. This is something that you can actually run if you check out the code. What I will say is sort of a trajectory. About, I'll say 5 to 6 weeks ago, we were failing over 1,100 of the specs. And as of last time I ran, about a week ago, that number had gone down to about 500. So when you think about the community, that was because people are contributing, and they're knocking out tens of spec failures at a time. So in general, what we're doing with the specs is we're trying to be as agnostic as possible with the implementation. So there's guards in there so you can specify that something should pass on JRuby, for instance, or that you extend something that's not incompatible with MRI, or that something is only compatible with MRI. So the basic, in terms of philosophy, is simply to have something that it doesn't matter whether you're running JRuby, Rubinius, MRI, or IronRuby, but it's pegged to MRI. So that's our essentially the most important gauge that we have of are we being compatible. So questions about incompatibility are huge to us, and that's why we're putting so much effort into writing something that you can execute and tell in an instant, are you doing this the way MRI does it, or are you doing something that fails? It's an implementation that I very uncreatively called mini RSpec, and basically what it is that we did not, I don't know if that's changed recently because I quit trying to do it, we did not run RSpec. However, I think that the value in communicating specs versus tests is huge, and so what I initially did was wrote something that was extremely slow and sub-process, big mistake, required actually refactoring the specs a good deal a few months ago. When we did that, we wrote mini RSpec, which is pretty simple, and it is intended to be syntax compatible with RSpec. We use a little bit different structure to do specs for aliased methods because there's so many of them in core, and it's really a pain to try to get that behavior exact. So we use something that's quite a bit different. I call it shared behaviors, but it's not exactly the same as RSpec shared behaviors. And I don't have a recent run, but we were actually running the specs, and I think JRuby was running the specs with RSpec fairly recently. I don't know if Charles, are you still doing that? Okay, so apparently they're still syntax compatible with RSpec.
Let's give Brian a hand. I am not the best test-driven developer in the world, and Brian has really driven the specs from day one, and he's really been the heart of the spec, the specking, the speculos. I don't know. Trotter, yeah.
I was wondering if you could talk a little bit about I know you're saying you want to keep compatibility with Ruby, but you've also made a number of enhancements, right, as far as the way you handle exceptions in C, your backtraces. Could you talk a little bit about that?
Sure. So Trotter was asking about, where we make enhancements. I will call them compatible enhancements. So it's not necessarily a behavior that MRI does, but it fills a hole that maybe MRI has. So it's not necessarily something that we found that's incompatible. And I can actually, good setup, because I have those slides if we want to see them. So this is my end of presentation slide. And so a good example is the backtrace format. Now, the backtrace format is actually kind of a funky position because caller, the method caller, returns the backtrace format. And at the moment, we actually have caller return the format that's compatible with MRI. But the normal backtraces that you get if you, say, raise an exception and it hits the top is something that looks a lot more like this. And this actually highlights, I love these backtraces. Not to toot my own horn too much here, but they really give you some really clean information about what was going on there. So, we've got, let's see if we have a mouse? No. Okay. So, like on integer in that case, you can see that actually that's indicating that fixnum was the receiver class, so I called like one.times. But the implementation of times is actually defined on integer, so that when you go to find out what was really going on at that time, you know that you're looking for integer times and not fixnum times. We found that being a class-based language that for the most part has multiple inheritance by mix-ins, the ability to know where the code was really defined is invaluable. So another one is related to backtraces. These are People will recognize these. These are actually some of my slides from RailsConf Berlin. So a good example is this one, actually. Man, that font is small. Can you see that? Okay. So this one, for those of you in the crowd who have done C, know that this is really not something that you should do in C in relation to anything, really. What it's trying to do is read from the memory location 4, which definitely is not going to work. So in this case, Rubinius supports, unfortunately, one of the most complicated pieces of C code in the VM, the ability to turn a seg fault, so an invalid memory reference, directly into an exception. So that when image magic dies on you and you get an entire, you basically your processes just disappear and you're not sure why, now you get back traces instead. That indicate that not necessarily why it's seg faulted, that is we could go on for days trying to figure out, writing an implementation of why a seg fault occurs. But instead can tell you where it occurred. So, and this is my other fun, stupid graphs. So, yes, Chad. 5 minutes left. Okay.
The other is an actual question. The other implementations are challenged very much by the following three things. Object space, continuum, and selector namespace. Are you challenged by those things? And if not, do you have a similar approach?
Okay, so the question was, how does Rubinius handle object space, continuations, and selector namespaces? Yeah, do we have problems with them? That kind of thing. At the moment, yes, we currently have a problem with object space in the same way that JRuby does. They use, we have a small benefit in that we've written our own garbage collector, so we do have access to it, unlike JRuby. But on the other hand, we use a garbage collector that does what's called object moving, so that over time, as the objects that really need to live on, they're moved around in memory, so they're closer to each other. That helps with speed. It also helps with the actual memory, the amount of memory that the whole process uses. And I haven't been able to figure out how to implement each object when you have object movement, because knowing what the kernel of next object is actually a method called, or the kernel of each object is a method called next object, where you give it something and it tells you what's after it. That's a basic enumeration. Well, the definition of what the next object is when in the middle of running this thing, all the objects were moved in memory is very difficult, something we haven't figured out yet. So Achilles heel, yes. Continuations are probably our shining awesomeness. Rubinius uses what the small talk demigods called a spaghetti stack. And what that is that rather than using the C stack, as you call methods, you create this kind of fixed place in memory that goes from high to low, right? So as you call things, you keep getting lower in this memory and you keep track of what was going on right there. Instead, Rubinius actually has first-class method contexts. And what these allow you to do is that when you call a method, it creates an object. And that object stores all the information about what needed to be accomplished on that method call. And I have a short demo for that, actually. I might as well use it since I recorded it. Let's see. Okay, so, I got to see it down here. Okay, so this is me starting up Rubinius. And I'm going to make a class called thing method awesome. And we're going to call this thing called method context current. And what that's actually going to do is it's going to give you a method context object that represents the calling of awesome. And it tells you, it indicates kind of what was going on and where you were. And then you can actually you can look at it. You can say, okay, I was calling the method awesome. I was calling it on this object. The method was actually located inside the thing. And there's a block environment because I passed the block to it. And then I'm going to add a mix in. Again, doing the same thing, just returning the method context for that evaluation of the method. Should have typed faster, I guess. So, and then this is where you can see that it knows that it came from stuff. So you have all the information about what was going on right there. And that the spaghetti stack makes continuations trivial because continuation is just the ability to save a point in time and go back to it. So with a method continuation or with a method context object for a continuation, you just save that one. And then later on in time, you just say, all right, I want to basically roll back time to this exact spot. And that's what it does. So this last thing kind of demonstrates something else that I brought up earlier, which is the ability to see your code as data. And this uses, again, a built-in version of parse tree to basically extract and parse this code for you and give it back to you in a canonical form very simply. So we're good. Okay.
Are you planning to make the method context serializable?
Yes. The question was, do I plan on making the method context serializable? And the answer is yes. The only reason they're not currently serializable is because no one has written it yet. But there's all the information's there. It just needs a little segment of code to be done. And I think we're out of time. Okay. So,